UNIXtober is finally here, and I'm going to start the month by digging into this SPARCstation 5. I'm not intending to get the whole thing like completely up and running in this video. There's a bunch of stuff that needs to be done on it. On this one, because I know that it's at least somewhat working. It's mostly a bunch of little things, you know, death by 1,000 paper cuts kind of a deal. So I'm going to start in on that. I have some other videos planned for another SPARCstation, a SPARCstation 10 that I had mentioned in my summer pickups video, and maybe some other stuff. It'll depend on how the month goes. Now, this month is also the Classic Tetris World Championships, so when I'm not making UNIXtober videos, I'm going to be watching live streams of people play Tetris much better than I could ever dream of playing it. Usually this time of year, I would be thinking about the Portland Retro Gaming Expo and going and seeing the CTWC live. But, you know, there's other stuff going on that's preventing that, that's expo blocking us. So in order to get started on this SPARCstation, I'm going to have to diddle around a little bit with a funky video cable. These SPARCstations have a goofy video interface that a few other vendors also used called 13W3. Fortunately, there are adapter cables made for that can bridge from crazy 13W3 interface to plain old VGA, and most computers that use that kind of interface can be made to work with most modern, which they're now relics of the past, but modern VGA monitors. So let's go ahead and just dive right on in. This is the 13W3 cable that I mentioned in the previous section. On one end, it has the goofy 13W3 connector, and on the other end, it's just plain old VGA. Now on this side, there's a set of dip switches, and I'm assuming inside this molded plastic housing here, there's some kind of electronics. The different dip switch positions configure the cable for the different kinds of computers that it might be connected with. There are 3 different kinds of settings for SGI computers, primarily depending on what kind of sync they produce. There's a different configuration for IBM Power-based computers, and yet a different configuration for Sun-based workstations. There were several variations of this cable. There was another one for 13W3 and a version for connecting an old like 68K Mac with the 15-pin connector to VGA. And then there were also variations that went from Mac or 13W3 to the 5 BNC cables. Really high-end, super expensive monitors way back in the day had 5 BNC connectors, one each for red, green, blue, and I believe H-Sync and V-Sync. So it was just the VGA cable kind of exploded out into different kinds of connectors. So I'm going to put the description of what this cable is in the description for the video. Now, I purchased this cable at the same time when I bought the O2. The O2 doesn't need this. It has its it has its own issues connecting to VGA. It gives some goofy sync that not all monitors like. I want to say it's sync on green, or I don't remember. So there's something weird. I have some monitors that work with it and some that do not. But the person who sold me the O2 also had this cable and for sale, and he only wanted a few dollars for it. And I thought, someday I'm going to need that cable. And then, you know, fast forward, I want to say 3 years, and I got the 2 SPARCstations, and lo and behold, I need this cable. So while we're here, I'm going to go ahead and pull the lid off of this. Now, I've already been inside here. The lid is held on. There's 2 screws on the back that are captive screws, which is such a nice feature because then you never lose them. But it kind of clips in a somewhat inconvenient way, and it's a little bit of a hassle to kind of pry it off. I did not want to wrestle with it a whole bunch of times. I knew I was going to have to get inside this case a bunch of times to do various things. So I just kind of have it sitting on here loosely. The other thing about these case tops, often these SPARCstations were sold with giant CRTs. Like when I was at Portland State University, I know we had a couple in our lab that had 21-inch CRTs that weighed, I don't know, 1,000 pounds. They were ridiculously heavy. And I want to say that some of them were Trinitrons and were just, yeah, you'll throw your back out. Even when you're young and in college, you'll throw your back out. So this thing is solid. It is a heavy piece of plastic that is reinforced with metal. Like, if Vikings come to raid your village, you could use this as a shield and you'd be all right. This thing is solid. Now, inside, this thing has a MicroSpark 2 CPU at 85 megahertz. This is kind of the time period correct analogy is this is the SX version of the SPARC. It also has the Turbo GX graphics card, which is a 8-bit color graphics card. I believe that it does some acceleration, but not a huge amount. The SPARC 5s also had this weird extra connector here for a graphics card. As far as I'm aware, these are the only SPARC systems that had that particular slot, and I think there was only one card ever made for it, and it was... I know it was a 24-bit color card, but I want to also say that it was an unaccelerated 24-bit color card, so it was pretty rough. I think the idea was that this was a faster bus interface, so if you had an unaccelerated card, having a faster path to the CPU made it a little less painful. There are 2 other expansion slots in it for the usual kinds of expansion cards, other SCSI controllers, more Ethernet controllers. I believe that the onboard Ethernet is only 10 megabit, and that for MBus you could get quad port 100 megabit cards, so a pretty substantial upgrade in the network bandwidth. It has 8 of these memory slots that sure look like SDRAM DIMM slots, but they're not. They take regular DRAM, and Sun gave them some clever name like extended SIM slots, or I don't know, something silly like that, but they're DIMMs. they're DIMMs by a different name and a slightly different kind of configuration, but for all intents and purposes, we can call them DIMMs. Pardon me. This is sort of the moral equivalent of the Dallas chip. It's real-time clock and calendar, battery-backed NVRAM, and the battery is inside the little plastic case. The other thing that is tracked on this little non-volatile storage is the MAC address for the onboard Ethernet card. And these digits on here are the last digits of that MAC address. Now, what I've been told is the reason that they did this is there was quite a bit of software for these kinds of UNIX workstations that was super expensive to license, like tens of thousands of dollars to license. Things like packages like Mentor Graphics and CATIA and other things. And the way that those software licenses worked is they would only run on a machine that had a particular MAC address. So if your motherboard died, or you upgraded your machine, or a bunch of other reasonable kind of things that might happen with a computer, right? You wouldn't want to lose that investment of tens of thousands of dollars in software. So you could just, on the new board or computer or whatever, you could just reprogram it to have the same MAC address as the old one. Now, that didn't mean that you could install the same package on 50 computers in your lab, because you couldn't have all those computers with the same MAC address on the same network. So I guess it worked. I don't know. It seems weird and kind of sketchy to me, but whatever. In addition, this has two SCSI hard drives. They're stacked on top of each other, and these little cage things are kind of irritating, so I'm not going to take them out. They are connected by SCA, which is a sort of weird SCSI plug that delivers both the SCSI bus and power over a single connector. The SCA connector also configures the SCSI ID instead of having separate jumpers on the drive to do it. There is an additional SCSI connector over here and a little power connector. I'm assuming this is for a CD-ROM drive. This faceplate comes out, so there's a place to put one, but this seems short to me, the way that it fits into the case. I don't know. Maybe the drive would actually fit, or maybe, I don't know. Maybe Sun sold proprietary short drives that they charged you 10 times as much for or something. I don't know. I'm going to end up mucking about with that later. The also has a floppy drive, and the floppy drives in these Sun systems are a bit like the 3.5-inch floppy drives in old Macs, in that they have, and I guess it would probably be, this looks like the motor for it over here. They have a built-in eject mechanism. Now, what I don't know is if they have the same disintegrating gears as the floppy drives in old Macs. So it'll be interesting to see if this floppy drive will still eject. Now, even if they do have disintegrating gears, people probably didn't use the floppy disks as much on these Unix machines as they would have on, a 68K Mac, for example. So, they might disintegrate, but just have not had enough use to have disintegrated yet. The other thing I forgot to mention, so the battery in this chip is absolutely dead. Years and years ago, I have purchased a replacement chip for it that I have. In a later video, I'm going to replace this chip and reprogram it. I'm going to go through all that, but that is a later video. For now, I'm going to reconfigure things around here, and I'm going to connect this up to a monitor, power it on, and see if I can do some magic from the firmware prompt to actually get it to boot off these hard drives. I have no idea what any of the passwords are, so I won't be able to get past booting up, but at least I'll be able to check that, these drives work and that the memory is good and yada, yada, yada. So I'm going to go ahead and do that. All right, well, everything's put back together and set up, so let's go ahead and turn this thing on. Now, the one thing I will warn everyone about is these things are loud. This was way before the whole revolution of, hey, let's make fans quiet, and hey, let's make hard drives quiet. Like, these are loud. This has two SCSI drives in it, and they both sound like leaf blowers. They are so loud. And so after I turn this on, we'll actually be able to individually hear them, each drive individually spin up as the system probes the SCSI bus and turns them on. I think after that, I'm going to use some software to try to denoise this, because, oh man, it's pretty rough. And it also, there's the first drive. And in just a moment, the second drive will spin up too. And there's the second drive. So, yeah, this would not be a system back in the day to have in your bedroom running your BBS on while you're trying to sleep, because you won't sleep. Ever. It also takes a really, really long time to get its stuff together and power on. So I'm probably going to have a hard cut right here. All right. So from the time I said there's going to be a hard cut until the screen lit up, it was a full minute and 15 seconds. So it was, from the time powering on, it was, I don't know, two minutes until you actually got to a command prompt. Now, this is the evidence of the NVRAM being dead, and we can try to dump it. And so everything in the NVRAM is A's, which is alternating 1 and 0 bits. The other pattern of alternating 1 and 0 bits would be all 5s, but so far this has always been all A's. There is a command to program this to set the serial number of the system and the Ethernet MAC address, and it will automatically calculate the checksum. However, well, I can go ahead and we can just do that. Let's do a couple other things first. Okay, so usually what you would do is, so while vintage home computers would boot up into BASIC, Sun's boot up into Forth. So I'm actually going to type some Forth code, and it's weird. I've never experienced this before. So I'm going to specify the command that would program the MAC address and the serial number. So these first digits are, so this is going to be the MAC address. This identifies that it's a Sun adapter. This is Sun's range, and then coffee is just, something clever that fits in 6 hex digits. And then I'll use the same thing for the system identifier, and then MKPL. Now, when you run this command, it just sits there, and apparently you're supposed to hit Control-D, Control-R. So when it gives the copyright, that means it didn't actually do anything. And you can see that the values are the same. What I have found is there's another command that is essentially like the poke command in BASIC that you can use to set, that can be used to set individual bytes in the NVRAM. And if the format and system type bytes aren't set, this other command always fails. So just set those 2 bytes and then use this command. There is another way to program this by doing the poke command, basically to program the whole thing, but it's a hassle. So, so set 1 at byte offset 0. What is it? MKP. And then 80, which is the system type, at offset 1. And then this other command will work. Whoops. If I type it correctly. And it just said okay, so that means that it worked. And ta-da, it worked. So there's a few other commands that we can do on this to sort of check this system out. It's already tested the memory, so I'm not going to do that. And it has, so those memory sticks, each one must have been 32 megabytes, which is the largest. This kind of system can either take 8 megabyte DSIMs or 32 megabyte DSIMs. So this obviously has 2 of the 32 megabyte DSIMs. So we can do, what is it? So this will probe the internal SCSI bus. There's another command, probe SCSI all, that will try to probe all of the SCSI buses, but apparently that command can sometimes be dangerous and can corrupt disks, so I'm gonna avoid that. So there's 2 disks. I can set one of them as bootable. And the thing that's weird is, remember the SCA connection, the way that particular kind of interface plug works, that sets the SCSI ID of the drive. So SCSI ID 3 is the primary drive in Suns. And so it's kind of weird if you do set env boot device and you say disk 0. If you say either just disk or disk 0, that actually means SCSI ID 3. And then if you say disk 3, that means SCSI ID 0. All the other numbers work as might be expected, except those 2, because, why not? We can set that. So one other thing that I will do is I'm going to disable the power on diagnostics. I don't have this connected to a network, and one of the things that it wants to do is ping the network. And so when it boots up at this state with the diagnostics still enabled, it's going to try to ping the network and ping the network and ping the network and just keep doing that ad infinitum. And I don't feel like stretching an Ethernet cable over here and plugging it in right now. So I'm just going to turn the diagnostics off. So we should be able to reset. And it should come right back up and try to boot off that disk. And it says no. Okay. Wait, what did I set it to? Disk 0. Okay. So, device. Disk. So then the other one. Actually, wait. Now I don't remember what it was. Oh. Sorry, some of these things are backwards of what I think in my brain they should be. All right, so there was 3, which is 0. Okay, so then 1. All right, let's try this again. And it still says no. Okay, so I'm going to have to try something else and return in a moment. I've gone and created a couple of floppies. So these are actually super old, like more than 10-year-old installation images for Debian Linux, because that was something I could find on floppy to actually be able to boot onto this. And so maybe I can boot into basically a Linux recovery image and then poke at those disks and see what's going on with this. So put that there. So I'm going to end up speeding this up, I think, because the rest of this boot process off a floppy, it's a floppy, it's going to take a while. Nice. Well, that answers the question about the eject mechanism on the floppy drive. Disk 2. That's so sweet. On PCs, when you get to a Linux install screen like this, usually, as you know, a feature of how Linux consoles works, you can do Control-Alt and the function key to go to a different virtual console. The Sun keyboard doesn't have a control key. Well, I guess it... All right, I'm gonna have to play around and figure out which key this is. Maybe Diamond Thing Alt? Okay, I got lucky the first time. All right. So let's... All right, so this is the primary disk, SDA, so it has partition 3 and a partition 7. That's interesting. Okay, so let's try mounting that. Okay, well that explains why it won't boot from that disk. That disk is empty. And just out of curiosity, let's see what the file system is. UFS. So it is a proper Sun file system. It's just empty. And it's interesting that it's mounted read only. Okay, so it won't boot from the hard drives because there's nothing on them. Okay, all right. I wonder, does this... So this is a very old version of Linux. Is there a proc file system? Oh, there is. But what I would be looking for is something like memory... well, there's mem info and CPU info. Okay. So on very old, it's common on modern Linux to use less or something. You use a pager on CPU info and mem info on really old Linux kernels. And we are talking about 2.2.20. The files in proc, you can't seek on them. You can only read them. So you can't use a pager on them. It will fail and you will be irritated. You have to like use cat and then pipe it to less or something like that. But I don't expect the CPU info to be that big. So there's the CPU in this, and there's the mem info. Okay, so the system boots. The hard drives seem to work. The memory seems to work. The CPU seems to work. The only thing I haven't checked out is the network because I haven't plugged it into anything. This seems to be working. I'm going to leave it here. That was some really good progress. It boots. CPU and RAM all work fine. The floppy drive works fine, right? And ejects, right? The hard drives seem fine. They're just blank, so I couldn't boot off of them. That's fine. I mean, the only things that I wasn't really able to test was proper sound output. I mean, it beeps, so that's something. And the network. But other than that, like, I was able to check out pretty well everything on that system, and it seems fine. So my next video is going to either be installing the NVRAM in that, the replacement NVRAM that has a proper working battery, and getting some kind of a CD-ROM drive in it. Apparently the firmware on the Solaris machines, the SPARCstations, I mean, are a little bit picky about the CD-ROM drives that they'll work with. There's only certain, it needs to have some certain attributes. I want to say 5 12-byte blocks. There's something funky about it that not all drives have. So I need to see if I can track down an appropriate drive to use with it that's old enough to be like that, but also new enough that it can read burned disks. So this may be a challenge. And then try to get Solaris. I'm going to go with Solaris 2.6 on it. As far as I'm aware, there's no support in the Linux kernel anymore for 32-bit SPARC CPUs, and I don't have any interest in actually installing 10-year-old Debian on this machine. It would be even more useless than, like, is useful a thing with retro computing? I don't know. Anyway, so I'm gonna try to get Solaris installed on it and play around with it and, you know, take a tour of it. So it'll either be that, or it will be digging into the SPARCstation 10. As I mentioned in my summer 2021 pickups video a month or so ago, the SPARCstation 10 has some issues, and it's going to need some repair and some cleanup. It definitely has problems. It's entirely possible that I won't be able to get it working at all. I'll definitely do at least one video about it, though, to at least like show what's going on with it and take some kind of a tour of it. It might be very short and, you know, end with rest in peace. So it'll be one of those two videos. I'm gonna have to do a bunch of the things in parallel because some of the stuff on that system is gonna take a while to just do. So I'm gonna actually start that this weekend, and the ordering of the videos is just gonna depend on how things work out. So until the next time, try to remember the good stuff.